In today's lesson, we have two topics, and neither one is totally new. First, we're going to talk about solving systems that have three equations, which means three variables. And then the second topic will be negative vectors. So beginning with the systems of three equations, you see three equations there on the left. Usually they will have these variables, x, y, and z. I need everybody copy down those three equations right now. And what our first objective as we try to solve this will be somehow with those get two equations that have the same two variables in them. I don't want one that has x and y and one that has y and z. They've got to be the same variables. Today, we're only doing the easier type of systems. This system we can solve by having one equation where we get one of the letters by itself. In this case, we already have x by itself equals. Sometimes we'll have one where it's real easy to get x or y or z by itself. In a future lesson, we'll do a little bit harder way with some harder systems where it's not as easy to get x equals all by itself or y or whatever. Once we have one of these, we're going to substitute it in to both of these other equations. So in this first one, I'm going to change that x to a 3y plus the y that was already there plus the z is 56, which means I am looking at 4y plus z is 56. And check my work on this. Don't let me get away with any errors of writing down something that isn't quite right. Second equation, I'm also going to put a 3y in for that x. So I have 3y. And then I have the minus 2y and the minus 3z that were already there equals minus 25. So that means that I have y minus 3z is minus 25. Did I get that one right? That means I now have two equations. They have the same two variables, y and z. So now I choose how I want to solve it, either substitution or elimination. I'm going to choose elimination. That means I either want plus and minus 4y or plus and minus 3z. And kind of a toss-up, which one's harder or easier. Usually 3's smaller, so it's easier to get smaller numbers. But 3 times 56 isn't as easy as 4 times 25. So I think I will take that second equation and multiply it by a negative 4 so that it becomes minus 4y plus 12z equals positive 100. And keep my first one the same, 4y plus z is 56. And please give me a thumbs up, thumbs down. Am I okay, or have I made any errors at this point? Okay, thanks for the double check there. I see the thumbs up. My y's cancel, 13z, not a real nice number here, but we can do it. 13z is 156. And let's see, 13 goes into the 15 once with 2 left over. Bring down the 6, so 26, 13 goes into 26 twice. So I believe z is 12. Okay, we are going to be writing our answers on these XYZ problems as an ordered triple. Be careful. The first one that you find may or may not go in the first spot. These are written in the XYZ order. We just found z, so we know that the last coordinate of this is going to be the 12. Once I have one of the variables, I look back at my equations. Which other ones have a z in them since I just found z? Well, this one has a z, but I don't know either x or y. This one has a z, but I don't know either x or y. These both have a z, so I could use either of those to get y. So Gabe, would you rather use the one with the 56 or the 25 to get y? I don't care. Okay, Gabe likes the one with more positives in it. So we're going to take 4y plus z, which is 12, equals 56. I want you writing down this work. I don't want you doing it mental math. Too many places to make mistakes. I can't help you find it if I'm not seeing your work on it. Subtract the 12 on both sides. 4y is 44. Divide both sides by 4, and y is 11. X, y, that one goes in the middle spot. That leaves z, so now I know everything except for the x. So I need to use any one of the equations that has an x in it, because that's what I'm trying to find. So these two over here can't help me get x. There's no x in them. So we're back to our original 3. Elias, which of those original 3 would you rather use to get x? Sounds good to me too. Let's use the x equals 3y, which means 3 times 11, or 33. So that means that my final answer is this ordered triple, parentheses, 33, comma, 11, comma, 12, parentheses. Must have the commas, must have the parentheses. Questions from anybody on that? Okay, let's move on then to negative vectors. You know lots about negative numbers. You've been working with those for years. You know that you have your starting point at 0, and if it's a positive, you go one direction, and if it's a negative, you go exactly the opposite direction. We've recently learned that negative angles also have the same starting point, but if they are positive, we go around in one direction, and if they are negative, we go around in the other direction. Negative vectors are also going to mean opposite direction. So if I have some vector, if I had a positive at some angle, I don't know where I'd end up. Let's suppose that that was right here. That was the one with a positive number out in front. Now I'm going to have a negative vector, so I'm going to put a minus out in front. So this is now a negative number out here at some angle. I'd figure out, well, if it had been a positive instead, it would have gone here. That's why I drew it with a dotted line. The real one is going to be exactly opposite, but that very same length long. So again, just opposite direction, but for a different kind of thing. So we're going to practice just graphing 2 of them and then doing a vector addition one where we have a negative vector in the problem. So first, if I wanted to graph negative 10 at 220, that one has a positive angle, so I need to go in the positive angle direction until I get to 220. So 90, 180, need to keep going a little bit, so about like that. And how many degrees would this angle have been right there? If I'm at 220. Kaylee? So everybody good with that's 40? 180 plus 40 more to get to the 220. And it would have been 10 long, but because of that negative, when I graph this, I'm really going to draw it this way for 10 units long. And how big would this angle have been, and how do we know that? Melissa? Perfect. It would also be 40 because of vertical angles. So then if I use this in a vector addition problem, it would be a plus plus. So I'd have the plus 10 cosine 40 for the I hat, and I'd have the plus 10 sine 40 for the j hat. Okay, let's do a similar one, except this time angle and vector have minus signs on them. So I'm going to start with the angle, because I always have to figure out where I'm going first. Negative 45 is going to mean I need to go in the negative direction for 45 degrees, dotted because I know I've got that minus sign out in front, so this isn't going to be my real vector. So I had to go down here 45 degrees. Because of the minus 4 out in front, I'm going to graph that exactly the opposite direction, but 4 long. And how big would that angle be? Riley? It would also be 45 because of being a vertical angle. This quadrant, left is negative, up is positive. So then if I needed that for a vector addition, it would be negative 4 cosine 45 for the I hat and plus 4 sine 45 for the j hat. So far so good from everybody. Give me thumbs up, thumbs down. Any questions? Okay, let's try one last example for today where we're going to add. The second one is what you're used to doing. The first one is the only part that's at all different, and that's only different as far as drawing the picture. And once we have the picture, it's exactly the same as what we've been doing all along. So for that first vector, I'm going to start off with the negative degrees, so I need to come down so that that is 15 degrees. But because of the minus out in front, I need to draw the solid one going exactly the opposite direction. So it is going to come up this way and be too long. And how many degrees is my reference angle? Mateo? It's also 15. In this angle, everybody positive, positive, or what are my pluses and minuses? Everybody. So negative, positive. So for that one, I'm going to have negative 2 cosine 15, no negative on that 15 now, and a positive 2 sine 15 for my I hat and j hat respectively. Now I do my second vector the way we've always been doing them ever since we started learning these. This time the angle's positive, so I go in the positive direction. 90 degrees, keep going a little bit. Positive number out in front. I'm actually going to draw this one, and that one needs to be longer. That one needs to be 5 long compared to the first one that was 2 long. What will my reference angle be on this one? Hayden? Perfect. It will be 70 because this much was 110, and I need the one with that x-axis. Same quadrant as before, so I'm guessing you're going to tell me it's still negative positive. So I'm going to have negative 5 cosine 70 degrees, and I'm going to have plus 5 sine of 70 degrees. Did I get that written down right? Does that look right to all of you guys? Okay, then I need you to punch that in on your calculators and store those as I and j. So you guys just said for I hat, your calculator said negative 3.642. And what about for j hat? Elias, what'd you get for j hat? Positive or negative? 5.216, you said? Thumbs up, thumbs down? Okay, so we double checked each other. So that would be our vector, our rectangular form for our vector. That's our answer. We look at that. It was negative, positive. So that means quadrant 2. No real surprise there, because if I went this way too, and then I went up at a steeper angle, both times I went left and up and then more left and more up, it makes sense that I'm ending up somewhere left and up. So my final vector, draw those end to end, my final vector looks like that. What I need to get to now is how long is that final vector? And what is this angle right here? So on your calculators, you are going to write down, or on your papers, you're going to write down what you enter on your calculator. R is the square root of your stored I squared plus your stored J squared. And do we have that already? I don't see calculators in very many hands. McKenna, you have that already? What did you get? 6.362. Anybody else getting that? Is that how long our final answer is? That's how long the final vector is. I don't need to write it down twice. I need to see the formula. This is what you typed in your calculator, but it's totally fine if you want to go ahead and write that answer down just over here, 6.362. Okay, now you're going to write down on your paper that rho is the inverse tangent of j hat over I hat. And then we're going to see what you get for that. And I'll label rho here on our diagram. It's going to be that angle right there. Okay, so you guys just were nodding your heads that on your calculators, you have something for rho. Is rho going to be my final answer? It's going to be this little acute angle. I'm going to need to do something to that to get the angle that really goes in here inside this at angle symbol. So yes, I want rho written down. So what did we get? Amelia, what do you have for rho? Others 55.077. And Amelia, great job remembering that we always write it down as a positive. Did your calculator actually say positive? So right now your calculator actually has negative 55 on it. But when we look at that, we would not say that's a negative 55-degree angle. We're just using the positive part of that. So how am I going to get the theta that I really want from that? Riley? Think about that again. Theta minus rho when you look at the picture. Okay, not what you're entering, just with the picture right now. What does the picture say? Is everybody good with rho plus theta is 180? When you look at the picture, rho plus theta, my purple plus my black up here at the top is 180. So that would mean that theta would be 180 minus rho. I want that written on your paper. Now we're going to talk about how you enter that on your calculator, and you would not be writing this down on your paper. Right now, your calculator says negative 55.077 over here on the right. You want 180 minus 55.077, correct? So you've already got the minus, you've already got the angle. The easiest way to do that is to hit the plus sign, which then immediately says take that last answer plus 180. So you have negative 55.077 plus 180. You see how that's going to give you theta? And Addie, do you already have that on your calculator for what that final answer would be? $124.923, is that what others have? And don't forget the degree sign, and that would be your other final answer. So not that calculator work, but the rest of that would be what I would be looking for on your homework papers.